Good afternoon. Today marks the 2935th lecture hosted by the esteemed Bangalore Science Forum. Our distinguished president of the National Education Society, Dr.HN Subramania, will be here now. So it's an honor for me to welcome Dr. Subramania. Dr. Kavi Mahesh, our esteemed speaker and a proud alumnus of National College, is welcomed with great enthusiasm. Thank you for being here today, sir. Furthermore, I sincere welcome is extended to the Honorable Secretary, Sri Venkat Shivareddy. It's a pleasure to welcome the Principal, Dr. Y.C. Kamla, and Vice Principal, Dr. Ramesh. A hearty welcome to all of you present here today. Our speaker, Dr. Kavi Mahesh, was till recently the director of the Indian Institute of Information Technology, Dharwad, and a professor of computer science. His areas of interest are analytics, knowledge management, epistemology, ontology, classification studies, and text processing. He has 3 US patents and has published 2 books, 16 book chapters, and 80 research papers. His experience spans both industry and academia in India as well as USA. He was earlier with PES University, Infosys, Oracle Corporation USA, and New Mexico State University, and has consulted in the area of knowledge management with Infosys, Hewlett-Packard, and United Nations. He holds an MTech in computer science from the Indian Institute of Technology, Mumbai, and an MS and a PhD in computer science from Georgia Institute of Technology, USA. A warm welcome to you, sir.
Good afternoon, everybody. As you all know, Bangalore Science Forum was started in 1962. The first lecture was held on 23rd November 1962. It was on the topic, the diseases of human civilization, by a Dr. Mahadevaya. And afterwards, in a span of 60 years, the Bangalore Science Forum has covered almost all the advanced topics, what we call today as the advanced. They were covered about the gravitational wave, about Einstein theory, or neuroscience, all the topics. The very purpose of Bangalore Science Forum is to communicate science from laboratory directly to the common man. The science is communicated from the first-rate researchers to the common man. So this was the ultimate purpose of the Bangalore Science Forum. The Bangalore Science Forum, apart from the weekly lectures, which is today's lecture is 2935th lecture, we do have conducted 42 science festivals. It is a month-long science festival in the month of July, and about 52 summer schools for 7th standard and for the 10th standard. The very number itself is mind-boggling. Doing one lecture is so difficult, and doing every week is very difficult. Year after year, it is further difficult. Running Bangalore Science Forum demands huge commitment and passion for science communication. Dr. H. Narasimhaiah, when he started, he all along 40 to 50 years, he used to sit in the front row itself and used to conduct the Bangalore Science Forum. Later on, in his legacy, we are continuing the activities of the Bangalore Science Forum under the guidance of our President, Dr.HN Subramania, and our Secretary, Sri Venkat Shivareddy. This is a brief, superficial explanation of the activities of the Bangalore Science Forum. The Science Forum later on started conducting seminars, national level, state level activities, Inspire activity, and many more. In the future days, we are also planning to conduct a very good amount of various activities from the Bangalore Science Forum. So today, Madam has already introduced Dr. Kavi Mahesh sir. His biodata is very impressive. Data science is need of the hour. We are already in Industry 4 and heading to Industry 5. Hope I am right, sir? Industry 4. And data science is the subject, and knowing about it, not only knowing, we need to practice. There is no second thought. ಸೊ ಕಂಪ್ಯೂಟ್ರ್ ಬರುವಾಗ ಕಂಪ್ಯೂಟ್ರು ಬೇಡ 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 ಅಂತಿದ್ರು, ಬಟ್ ಕಂಪ್ಯೂಟ್ರನ್ನ ಬಿಟ್ಟು ಬದುಕೋಕ್ಕಾಗದಂಥ ಪರಿಸ್ಥಿತಿಗೆ ಬಂದ್ವಿ. ಅದೇ ಥರ ಡಾಟಾ ಸೈನ್ಸು ಈಗ ಆಗ್ತಾ ಇದೆ. ಸೊ ಅದರ ಬಗ್ಗೆ ಹೌ ಡಾಟಾ ಸೈನ್ಸ್ ಈಸ್ ಅಪ್ಲೈಡ್ ಫಾರ್ ಇಂಡಿಯನ್ ಆಸ್ಟ್ರಾನಮಿ ಈಸ್ ಅ ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಸಬ್ಜೆಕ್ಟ್. Sir, once again, I welcome you and thank you everyone. So the lecture is for you, and many people, our alumni have come, seniors have come. So welcoming one and all of you. Professor Dinesha sir is here, Jamdagni sir is here. Sir, welcome you also. I welcome all my teachers and students. Thank you. Now over to Professor Kavi Mahesh.
A very good afternoon. Can somebody change that? ಸ್ವಿಚ್ ಮಾಡಿದ್ರಲ್ಲ ಬೇರೆದಕ್ಕೆ ಬಂದಿತ್ತು. ಇಟ್ಸ್ ಓಕೆ, ಇದರಲ್ಲೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಚೇಂಜ್ ಮಾಡಿದ್ರಿ, ನಾವು ಟೆಸ್ಟ್ ಮಾಡಿದ್ವಲ್ಲ ಆಲ್ರೆಡಿ. We came early and tested everything. In between, they tried to show that one slide and remove the connection. So Anyway, I'm very glad to be back in this college after 42 years. I was a student like one of you here in 1982. And I thank the management, Bangalore Science Forum, the principal and president and others for considering me and inviting me to be here today. The idea today, whenever this comes up, I will start the actual discussion, is to talk about data science, how it is different from science in general, and how we can use it. In particular, what I would intend to do today is to show how we can take data from Western science and apply data science to understand Indian science. So how can we take data from, say, NASA about the planetary motion, about astronomy, and do data analytics on it to understand our own Indian astronomy. That's what I intend to do. Right? So we will begin, it will not be effective because I have to show several animations, videos, and so on. So I hope this works and we will get started as soon as it works. Yes. I hope they don't try to fix it again. It's already working. So, I have a new affiliation. Just 2 days ago, I joined RNS Institute of Technology. So that is on the slide. So what is data science and how is it different from science in general? So in science, as you all know, normally we have laboratories where we conduct experiments, we collect data, we analyze the data, and gain new knowledge or come to conclusions. Data science is slightly different, and there are two versions of data science in my view. There is one version which is just a shortcut for doing science. Right? Suppose I don't have a laboratory. I may not have the world's best physics laboratory. So I will take data from some other laboratory and I do the same kind of science. So I'm just borrowing data from someone else. That is one kind of data science. The other kind, more radical kind if you wish, is I don't know that science. For example, I am not an astronomer. I don't know so much about, I'm not from ISRO or NASA. I don't know astronomy that well. But still I can take astronomy data and do science using that. That is the more interesting kind of data science, where you don't need to be necessarily the world's best expert in that branch of science to do science. And that is what I would like to illustrate today. So there's a lot of potential in doing that. There is a lot of potential for misuse also, right? For arriving at fake conclusions and so on. So one has to be very careful, but the potential is so high, as your principal said, if we don't do it, right, we will be left behind. Now, what does it mean? We collect and create large data sets, which have to be accurate data sets, high quality data sets, and we carefully apply methods of data analytics on it, which may be statistics, which may be other mathematical techniques, which may include even AI and machine learning and things like that. And to be successful in that, right, it is not sufficient just to be a statistician. Right? For example, if I have to apply data science to astronomy, I have to know a little bit of astronomy as well. On the other hand, if I only know astronomy and don't know data science, that is also not good enough. So one has to be good in both for this kind of a venture to be successful. Right? So what I intend to do, as I said, is create and show you how we can use data from Western astronomy and try and understand the kind of geometry, the kind of configurations, very intricate, very sophisticated configurations that have been put forth in our own Indian astronomy, which was called Jyotish Shastra. Right? It doesn't mean predicting who will win the election. That is not the part of Jyotish Shastra that we are talking about. The astronomy part of it, right? If you want to call it the science part of it, yes. So there are several ways of doing this. One can apply statistical analysis on the data to understand how a certain parameter or certain number behaves. Or we can go ahead further and simulate and create some animations. And I intend to demonstrate some of that today, just to show what is possible, right? And all of this is code written by myself. So this is using R, Python, PHP for those who are interested. And I will also show one of the technologies called SVG, Scalable Vector Graphics, how all of these can be applied to do this effectively, right? So first, where is the data? So NASA has got Jet Propulsion Laboratory, JPL. They have created perhaps the world's most accurate data sets about planetary motion, right? How do all the different planets move? What are their current positions if you are observing from a particular latitude, longitude, on a particular date, time, all of that. So it's a huge data set. On top of that, there is a package called the Swiss Ephemeris. So they have now sort of compiled it and prepared it and given us what are called the APIs, right? The interfaces, the application programming interfaces. So now I can write programs using those APIs to collect and curate my own data sets. So the starting point for me is to write some programs, say in Python, to curate that data. So for this study, I have taken 200 years, from 1900 to 2099, right? Most likely that must be the period of interest to us, the last century and this till the end of this century. And that period has 73,050 days in it. So for each of these days, I have created a data set which has 68 different parameters, for location being fixed as Bangalore. So this is just a snapshot of the data. You are not expected to be able to read it. So the idea is there are 73,000 rows in this, one for each day, and there are 68 columns. Lots of numbers are in this data. And this has everything I need to do any kind of analysis that I need to do. So what is the position of a particular planet? Everything is in this data set. So this data set is not extremely large. It is not into terabytes or anything, but it is quite large in the sense it has 73,000 rows and 68 columns. Now we as human beings, we have not evolved. Our brain is not, has evolved to read data and process data. Right? We are much better at seeing pictures and graphs and charts and animations than processing data. Computers, on the other hand, are designed to be good at this. So when these two come together, the programs can create the graphs and the animations that we can visually see and appreciate, and that will help us understand some of the intricacies of what is going on in Indian astronomy. Right? So I've built some simple applications first. This is not the focus of this talk, but just to show what is possible. Right? If you go, I will give the website later, you can go. For some bizarre reason, some strange reason you wanted to know all the holidays, list of our festivals in the year 2050, that's already available. Up to all the 200 years, whichever festivals you want to know, it's available. This program can generate it, right, given that data. So data is from NASA, and I am telling you which day is Makara Sankranti or which day is Narsim Jayanti in 2050. It's all possible because it so happens that all of these are astronomically defined. The dates of all of our festivals are astronomically defined, and I can easily compute all of that. Right? So it is there. You can go and get that for any day. Similarly, there are some traditions. People celebrate their 1000th full moon. Since I was born, how many full moons have happened? And nobody knows exactly how to calculate that. There's a lot of confusion for those who celebrate this thing. Is it 81 years? No, it's 81 years, 3 months, and so on. Now I can calculate it exactly. So you give the date of birth, it gives you exactly when you will see the 1000th full moon. Right? All of that is possible because it's all in the data. Right? So similarly, one of the things I thought was how to show all of this astronomical data in a visual form. Why not make it like a clock? Right? So nowadays we have no need for an analog clock anymore. Is there one here? See? There is no analog clock anymore. Nobody needs an analog clock. But the idea of a dial with moving hands is still a useful metaphor. So why don't we create a clock? Right? So I will just show you how. So this is a clock here. This clock is different from other clocks because each hand is the position of some planet. Right? So I've used Indian names, Ravi instead of Sun and Chandra instead of Moon and so on. Now this is of January 1st. So on the website it will show it for today, and if you keep refreshing it, it will show exactly where all the planets are currently. Right? And it will, whatever else can be computed, it will show all of those things. But if you had this open on your screen, for example, it will be extremely boring because nothing moves in this clock. Right? If you refresh it after 5 minutes, 10 minutes, pretty much everything will be the same. Right? So we need to change the scale. Just like maps are drawn to scale, we need to build this clock to a different time scale. Right? This, by the way, uses this technology called scalable vector graphics. The idea is normally when you zoom into any picture, it becomes blurred, whereas this won't. As much as your device allows, it can keep on zooming in without blurring the image. That is why it's called scalable vector graphics. So let's go back to the presentation, and let me show you what happens when you change the time scale. So here, instead of showing the clock for just one snapshot, so let's see what happens in this entire month of January. So I will now change the scale, the time scale. 1 second equals 1 day. So if I run this clock, every second it will change the day by 1 day. Right? See what happens to all the planets now. Yes. So now, each second, it is changing by 1 day. And you'll see which one will be the fastest moving will, of course, be the moon. Right? So you can see how the moon moves every day. It roughly moves 12 degrees per day. And you can see some of the others moving much slower. So it's again started from January 1st, 2nd, 3rd. So that is today, 4th, 5th. So you can see the actual animation of how all these planets move. And those who know Indian astronomy, it shows many other things. You can study all of those, whatever is there in various so-called aprakashaka graha. So many other things are shown. Whatever is computable from that data is all shown here. That is just to visualize how the planets move. Now, what if I wanted to see for a whole year? So let me show you entire 2024. So these used to be printed in books, right? And what is traditionally called the Panchanga are also in tables called ephemeris and so on. Now we can animate the whole thing. So this is even moving much faster. It is moving at the rate of 4 days per second. So in just about 1.5 minutes or so, it can show you how, what will all be the planetary motions in the year 2024. So the date keeps changing here. We are already moved to March. Right? So you can see there's that cluster of Mercury, Venus, Sun moving, and then the Moon moving the fastest. And because we are observing from the Earth, at some points, some of the planets appear to be moving backward. That is called retrograde motion, apparent retrograde motion, or vakra. So in this, it is shown by changing the color to red. So if that planet, later you will see, I can even fast forward. Because it's a video, I can stop it, I can make it go backward, forward, do any of that. Right? It is recorded. So at this point, for example, Shani, Saturn is appearing to move backward, so it has changed its color to red. So for teaching astronomy or for understanding astronomy, this kind of an animation can be, Buddha, Mercury is going retro now. So all of that can be created, right? To visually see how and the data is all from NASA, but the application is for understanding Indian astronomy. That is one aspect of it, right? So for those who are interested, you can explore that in greater detail. I will not spend much more time on that. Then even larger time scale, right? So which is the slowest moving planet? It is Saturn, right? Shani. It takes almost 30 years to make one orbit around the sun. That means if the Saturn was in some position when you were born, by the time it comes back to the same position the second time, you're a senior citizen, right? It's 60 years. That is how slow it is. So can we animate that as well? I was just trying to see. And so this is 80 years of data. And you, of course, if you show everything, it will get too cluttered. So here, only the outer planets are shown. Mars is called Kuja, Shani is Saturn, Guru is Jupiter. The other ones move too fast in this time scale, right? So this is 1 second is 1 month. So this is the time scale here. So for every second, it moves by 1 month. And you can visualize now the entire motion of Jupiter and Saturn and Mars, say in your lifetime. So this starts in 1960. So each time it is moving by 1 month, or it's actually 30 days exactly, not 1 month. So you will see that these outer planets go retro a lot. They move backwards quite often, because that is how it appears if we are observing from the surface of the Earth. So Guru, Jupiter, makes one revolution in 12 years roughly, whereas Shani takes almost 30 years. Mars takes about less than 2 years. So it is moving much faster than the other ones. So they make a big deal about all this in the predictive part of Indian astronomy. You might have read on newspapers and all this saying, transition, Guru transition, Shani transition happening. It's happening all the time. Every time it crosses any of those radial lines, that is what is called a transition. Right? It keeps happening all the time. So that you can visually see here. You can also stop, if you want to bring it to today's date, you can now fast forward this or bring it to any particular. Right? So this is 2008, 13, 2016, 2020. Right? This is about now, 30th December 2023. So you can now go do all of that. Right? And then here there is a red line, Rahu and Ketu. Right? What are these? They are nothing but the points of intersection of the Earth's orbit and the Moon's orbit. So the Earth is going around the Sun in a particular orbit. The Moon is going around the Earth in its own orbit. These two are not in the same plane. They are tilted slightly by about 5 degrees or so. So it is as though those two elliptical orbits keep intersecting at 2 points. Those 2 points, they move backwards at a very slow pace, about 1 revolution in 18 years. You can see that also in this. Right? This red line here, it always keeps moving counterclockwise. So as every 30 days, you can see that it's like another clock dial which keeps moving at uniform angular velocity. So you can see all those transitions and all of that by creating these kind of animations. But that's not the main point of this, what I'm trying to show. Let us go back and see what kind of analysis we can do, right, based on all of this. The first topic that I would like to take up is there is something called Rashmi Phala in Indian astronomy. This is not very popularly known, but it's very interesting because it proposes a kind of an aggregate score from all the positions of all the planets. It's like a total marks that you get in a marks card. For each day, you can calculate, Parashara in his text gives a detailed account of how to calculate that Rashmi Phala. And he says, if it is 10, less than 10, greater than 40, and so on. But what exactly is it? How do we know what are its range of values? So I went ahead and calculated it for 120 years each day, 1900 to 2021. What is the value of this so-called Rashmi Phala? Right? So this is the method of data science. I have the data. I will create large computations. So if you look at these 44,559 days, now I have the data set, Rashmi Phala, for each day. It turns out that its minimum value is 2.2, maximum is 52.8, right? But its mean and mode are around 24, and then it has a standard deviation of 7, all of those. So this is now bringing in mathematics, statistics, data analytics into understanding something which was proposed in Indian astronomy. And in fact, it turns out that it has very low values very infrequently. It's less than 5 only on 48 days out of these 44,000. After 120 years, only on 48 days its value is less than 5. Only on 19 days it's more than 50. Right? So what does it indicate? If I plot its frequency distribution, histogram, it is normally distributed. It has the famous bell curve. So you might know that almost everything in nature is normally distributed. Our height, weight, IQ, everything is normally distributed. So this is also such a natural phenomenon. What exactly it denotes, we don't know at this point. But it does have a normal distribution. If you plot it month-wise, so this is English calendar months, January values, February values, and so on across 120 years, there does seem to be a sort of seasonal variation. Right? So March, April, May, it is higher than, say, in October, November, and so on. But within a month, there is a large variation. Right? So this is just a scatter within that month, all the different data points. There is too much variation there. If you plot it across years from 1900 to 2020, right, it is not purely random. There seem to be some years when the Rashmi Phala values are very high, some other years that are quite low. So one possible, one conjecture, something that I have not yet done, one possibility is to see if this is related to monsoon rainfall, for example. Right? So you can get rainfall data, see if there is any kind of correlation between this across years and the monsoon rainfall. One can do such studies once you have these data sets. So that is another potential of data science where you can go across domains and see if there are correlations. I don't need a physical model of monsoon rainfall to do that. It's going to be purely based on data. So similarly, you can do it across. A mean value of that across years is also normally distributed. And if you plot it against monthly, as I said, right? So it is very high in April and lowest is in October, November. So it has got a seasonal component. For those who know, there are methods called time series analysis. Now you can apply time series analysis methods on this to further see what kind of cycles and periodicities exist in this data. Right? So if you plot it against our lunar months, you get a similar pattern, not very surprising there. But if you plot it against some other things, against date, let's just take, it looks like somehow it is always low on the 14th and 14th and 15th of the month, but 16th and 17th, suddenly it goes up. Right? So this is one of the biggest pitfalls of statistics or doing data science. Before we get too excited about such a thing, we have to notice what is the scale on the y-axis. Right? It is not at all significant, this change, because it is from 24.0 to 24.3. So whereas in the previous plots, it was 20 to 30. There was a significant variation. This is done intentionally just to show you how we can get misled. A very small change, it is not at all significant. So many such things can be confusing when we are doing data science. We should be careful about jumping to conclusions There is really nothing special about 14th and 15th of a month. Or if there is a small significant variation, I don't know why it is there. We'll have to figure it out. Right? Similarly, if you plot it against our nakshatras, the divisions of the 360 degree into 27 parts, here you see another interesting pattern, but it is not very significant anyway. So I will skip that part. And now go back to understanding some of the other concepts in Indian astronomy using animation. So one way is I have a certain number that can be computed. I'm going to do it on a large scale and apply statistical analysis on that. The other way is to visually see how things work, right? So before we go to that, just understand some of the basics. There's a lot of mystery about all this, but really it is all simple geometry, right? Especially if you know circular geometry. So what we call tithi, right, is nothing but divisions of 360 degrees into 30 parts. So you take the difference between the longitude of the moon and the longitude of the sun. Theta moon minus theta sun divided by 12. So every 12 degrees of separation between the sun and moon is what we call a tithi. So there are, if you divide 360 by 12, you get 30. So there are 30 tithis. As simple as that. Nakshatra is nothing but the position of the moon. So you take the longitude of the moon, theta moon, divided by 13.33. You get 27 parts. That's why we have 27 nakshatras. So it is just the nomenclature can be confusing, but the maths behind it is quite simple. So you have 12 degrees giving us 30 tithis, 13.33 degrees giving us 27 nakshatras. It's a different matter that each of them is further divided into 4 parts, and 27 into 4 is 108. Right? The number 108 keeps coming back in every Indian science. But there is another interesting concept called yoga. This is not the Patanjali kind of yoga where we do asanas and so on. This is the yoga in Indian astronomy. Right? One of the panchangas, in the panchangas. That is interesting because it adds the angular position of the sun and the moon. It is theta moon plus theta sun divided by the same 13.33. So again you get 27 of them. But what does it mean to add the longitude of the moon and the longitude of the sun? So it is quite difficult to understand that. And then add one more concept to that called Yoga Nakshatra, which is the 7th nakshatra from that. So it is whatever you get from that previous computation plus 6 added to that. So let us see how that behaves by trying to animate that. So it is just, again, 1 month of the movement of sun and moon, along with this yoga now being shown. So here only Ravi and Chandra, sun and moon are shown, and the sum of their, so I will pause it at some random point. So here the sun is on the left, right? The moon is here. If you add these two angles, you get this angle. That is what is called yoga. So sometimes that happens to be between the sun and the moon, sometimes it is to the left, sometimes it is to the right. And the other one, which is adding 6, is literally just the perpendicular to that, right angle to that. So this is how yoga behaves. What is its significant? I am not quite sure. Right? Some of them are supposed to be good, some of them are supposed to be bad. So in this, whenever it is supposed to be good, it is colored green. When it's supposed to be bad, it is colored red. I was just trying to visually see if there is some pattern we can notice, and when it becomes green and when it becomes red. Right? So if you see that yoga line, now it is, sometimes it moves pretty close to the moon, sometimes it doesn't. So it is sort of an independent concept, very unique to Indian astronomy. So what is the meaning of adding the position of the sun and the moon? But that is what is yoga. And creating this animation is one way to understand what that might be. Right? Going on, now beyond that, they were looking for various kinds of symmetries. So there are two kinds of yoga called Vyatipata and Vaidruti, where it is, here is a circle here, on the diameter, on the circumference of the circle are positions of the sun and the moon. Whenever they are aligned on any of these vertical lines, that is at the top maybe the sun, moon may be at the bottom, or vice versa, right? It's all in terms of angles only. Don't worry about the distance from the earth to the moon or distance from the earth to the sun. That doesn't matter here. There is something called ayana, that is, there is equinox and then there is solstice. We just had winter solstice on December 22nd, right? And so because of that, the point where the sun and the moon rise, they keep moving north and south. The sun rises exactly in the east only on 2 days in the year. What do we call those days? They are the equinoxes, right? On all other days, it's either rising to the north of that point or to the south of that point. That is one kind of motion. The other kind is its angular position. So there is the Kranti and Ayana. So when they are so aligned that they are on the same side of this circle and they are at the same Kranti and equal Ayana. So that means it is any of these vertical lines that I have drawn here. That is one kind of symmetry. The counterpart of that is the other one, where the sun and moon are aligned on one of these horizontal lines. Here again the angles are equal, right? But they are on, one is on the left, the other is on the right. So you get the horizontal line. In the previous case, one was above, other below. Above and below, all that I am using very in abstract ways. So this was known in extremely ancient period. This is found in texts much older than Aryabhata and so on. Some of the oldest texts talk about this. So what exactly is going on here? So I have tried to create an animation to show how exactly this behaves. So on this screen here is again the positions of sun and moon will be shown, but there are two blue lines, right? This is the equinox line and this is the solstice line. What does it mean? That means if the sun appears to be close to this, that is your spring equinox. On that day, the sun will rise exactly in the east and day and night will be equal. This was the winter solstice that we just had on December 22nd. That's why you see on 1/1/2024, that is January 1st, Ravi, the sun is just ahead of that winter solstice line. So in a year, it goes through that. Similarly, this is the summer solstice line and this is the autumn equinox line. Now, if you draw an imaginary line from the sun to the moon, again, not a physical line from the actual moon to the actual sun, the line from the angle of the sun to the angle of the moon, that line, whenever that line is parallel to these blue lines, that is what they have defined. That symmetry is what they have defined. So let me run this and you will see that what happens in this animation is whenever the two are parallel, it draws a red line there. So this keeps happening every month on a particular day. So what could be the reason for studying that? Why is it important? Right? So maybe something on some kind of a force, because now the lateral pull of their gravities may be getting cancelled. Sun and moon are together pulling the earth in one direction exactly on that day when that line is parallel to this. So for this you have to calculate what is called the tropical coordinate. This is the one aspect, only one concept perhaps in all of Indian astronomy where we don't follow sidereal coordinates, right? Not Nirayana but Sayana. We should not follow sidereal coordinates but use tropical coordinates only for this concept. And that is clearly mentioned in the text. Because the idea is this blue line is not aligned with the other lines because of what we call precession of the equinoxes, right? So that angle, the blue line rotates very slowly at the rate of 1 degree every 72 years. So in a few centuries, it will have moved a little bit. So this is a phenomenon which happens once a month, where there is this perfect symmetry between the positions of the sun and moon with respect to these equinox and solstice lines. And that was known in very ancient times, right? And they have given us that in this sutra form. Let me close some of these animations. So that is another concept which we can understand by trying to do that, create that animation. Now, there was another thing called Ekargala, and it turns out that it is almost the same kind of symmetry that they have talked about in this, which I didn't know until I actually created some of these animations and visualizations. It simply is described as when the sun and moon are equidistant from the Yoga Nakshatra. So we saw what is yoga. Yoga is nothing but the sum of the longitudes of the sun and the moon, and the Yoga Nakshatra is the perpendicular to that. And now it says sun and moon must be equidistant. Distance again in terms of angles, right? Don't think of it as the astronomical unit kind of distance, not the straight line distance. So they must be on either side of that in equal angles. How often does such a configuration occur? Right? It turns out that it is quite rare. It happens about 120 times in a decade, so about 10 times a year. It doesn't even happen once a month. So if you plot that, for example, this is all the occurrences of that in 2024. There are only 10. And all those, so again I have drawn an imaginary blue line from the sun to the moon. Here moon is red, sun is black, and they all are pretty much on the same, in the same angle. Now, so I went ahead and did that for a whole decade. Now this is for 2020 to 2030. All the positions when sun and moon were such that this condition for Ekargala is satisfied. And you get these blue lines, and they all seem to be roughly perpendicular to this axis, the dotted red line. Why is that significant? What is its meaning? We don't know. So they use this in the predictive part. They will say, okay, we should not, when this happens, it's not auspicious. You should not schedule a wedding and things like that. But why, what is the significance of that? So it looks to me it appears that this is almost the same as the other one, the Mahapata, except that was with respect to tropical coordinates. This may be with respect to sidereal coordinates. But this is again, they were looking for these kinds of symmetries. And that's not apparent by just studying the shlokas or the text. Only when we go into that and use the data to create this, it becomes clear that. So in terms of the actual, let me go back to the slide. So if you go back to this, it only happens whenever the Yoga Nakshatra is Purvashada or Uttarashada, which is simply saying when the angle is 253 degree 20 minutes to 280 degrees. So that is the angle that I got in that dotted red line. It can only happen then. But if you Google about this Ekargala and read all the web pages that are there and books, what people have written, they have written it for all kinds of configurations which are impossible. They never happen. Because it can never have that kind of a symmetry, can never exist when the angle is not within this range. At least that's what my data shows, these 200 years shows. So what is the significance of this? We don't know at this point. At least I don't know. Right? Similarly, the Parashara defines something called Maharaja Yoga. Now, whether we believe that with somebody becomes Maharaja by having that yoga or something, what is the planetary configuration that is defined and how frequent is it? If it is very frequent, it cannot be significant. Right? In life, everything that is very common is very average. Right? Everything that is common is average. So if it is something special, it has to be very rare. Only then it can be special. Now, for example, in all these newspaper, magazine, and TV astrology, oh, I am an Aries, you are a Leo, and so on. Well, there are 1 billion other people who are also Aries and 500 million other people who are also Leo. So that cannot be very significant. No one can make any predictions based on those things. Right? It's just too common. So what is that extremely rare configurations that our people have tried to create? So here, there is a kind of symmetry that is prescribed, which says, we have something called Lagna, which is nothing but ascendant, which means whatever is at the eastern horizon at that point is called ascendant. That word is misused in many ways. In northern Karnataka, Lagna means getting married. Right? That's not what we are talking about. So that, it says there should be an exchange, a symmetry between that and the 120-degree point. 120-degree point, why is that important? Because it is, you divide the circle into 3 parts. You get 120, 240, and 360. So there should be an exchange of the 2 planets between the point of rising, ascendant, and the one that is 120 degrees away from that. That is the first rule. Right? So that occurs quite often. But there's a second rule which says Atmakaraka and Putrakaraka should also be in this 0 degree and 120-degree point. What are these Atmakaraka and Putrakaraka? So you take the longitude of any planet and take the modulus 30. That is, you divide it by 30 and take the remainder. Right? Whichever one is most ahead. So it's, imagine some kind of a race among all the planets. Whichever one is most ahead within that 30-degree range, that is what we call Atmakaraka. Now, Putrakaraka is the one which is the 6th most ahead. So you have to take all the positions of all the planets, sort them, in terms of this Amsha, and take the first one and the 6th one. They, it says, should be in mutual positions. The one at 0 should be at 120, 120 should be 0. That's the second rule that is prescribed. So how often does this occur? Or is it even possible? Right? So I had the number somewhere. Yeah. So if you take 200 years of data, that is 365 days into 200 years, there can be 12 different ascendants because the Earth is spinning at a uniform speed. One full rotation in 360 in 24 hours. So each 24 hours, each division of 30 degree will rise in the east at some point or the other during that day or night. So into 12, you get 8,76,600 possible configurations in these 200 years. Out of this, if my programming is correct, if there are no serious bugs in what I have written, this occurs only 459 times out of 8,76,000. So it's an extremely rare configuration what they have prescribed. Right? So it's about 2.3 times a year. So this is stated beautifully in a shloka, right? For those of you, National College is the source of all our knowledge of Sanskrit. We were taught Sanskrit so well in this college. So I will state that shloka as well, right? Lagneshe panchame bhave panchame cha lagnake, right? Putratmakarakau vipra lagne cha panchame sthite. That is what I have just described. All these calculations is given in just that shloka. And then, if you think that is all, there are 4 additional rules given. I will not get into the details of that. Svoche, swamshe, swabhe, vapi, shubhagraha nirikshite, maharaja khyayo gotra, jatah kyatas sukhanvitaha. That is the shloka which gives the entire calculation of all of this. So those 4 rules also, if you apply strictly, it will never happen. At least in 200 years data, that exact configuration that is described never happened. And maybe that's why we don't have Maharajas anymore. Right? In these 200 years, that exact configuration never occurred, that planetary configuration. But before I conclude, there is one more rule that is added to this. It says in the previous part of the text, you should also consider this from Karakamsha Lagna. So what is that? So we already talked about Amsha, this modulus of 30. You take now the Atmakaraka, the one which has the highest value of that Amsha, find its position, convert it to what we call Navamsha. Right? It's a kind of a geometric transformation. I will not go into the details of that. But mathematically what we do is, we take the angle theta, divide by 3.33. Why is 3.33? Because 3.33 will divide 360 degree into 108 parts. 360 by 108 is 3.33. So divide by 3.33, again divide by 9. That's why it's called Navamsha. Essentially, you're dividing the entire circle into 108 parts. So every 30-degree part gets divided into 9 parts, and then you rotate them. So the first part stays right there. The second one goes to the second block. The third one goes to the third block. Fourth one goes to the fourth block. Cyclically, circularly, you do this. Right? That is called Navamsha. So do that, and then the value should come back to the same place. So that is Swa-amsha. So you do this for the Atma Karaka, you get what is called Karakamsha Lagna, then apply all the other rules again. So it was very confusing even to write the code to simulate this. It can be very confusing, but that's the kind of sophistication they had. That's the kind of sophisticated patterns and configurations they were imagining. And when I did that, this is even more rare. It happens only 240 times in this 200-year period. So it is roughly, out of 73,050 days, this configuration occurs only 240 times. So whether we can make predictions or not from all of this, one thing is very clear, that they were able to imagine, calculate, and create these configurations of symmetry, whether it is between the sun and moon being equal at equal angles from some important line, or whether it is this exchange of positions at 120 degree. All of these are very sophisticated patterns. This is just some of an illustration to show what kind of things were constructed, concepts were constructed, and how we can recreate them now using Western data. Now, a lot more can be done if we had real data of our own. Right? For example, this has been a pet project of mine, which I have not been able to execute. Some of the traditional astrologers claim that no human being can be born in a certain configuration. I don't know, Professor Chamadagni may know about this. They say they say that's how they detect fake horoscopes. If somebody goes to a good astrologer with a fake horoscope, he or she will say this is fake because no human being can be born in this. Now that seems very strange, right? So that means human birth is not a random phenomenon. So the fundamental question will be whether the time of birth is a random phenomenon or not. Now, how do we verify that in data science? If I had sufficient data, now I can verify this hypothesis. But unfortunately, we don't have the data. So an appeal for data is what I'm saying. If we have data of at least 1 lakh or 1 million people, real data of their actual date, time of birth, and so on, now easily we can now program and verify that hypothesis, just out of curiosity, if nothing else. Right? So that is something to be done, but data is not available. You get data about VIPs and celebrities. We don't want that. We want data of common people. Right? You don't want only analyze Bollywood and Hollywood stars' data. That will not be a representative sample, to use statistical terminology. So in summary, I hope it was interesting, and what I have tried to do is to show that data science has the potential to be applied to any and every field, something as strange as what I have tried to do here. And we can take data from reliable sources, in this case from NASA, and apply it to understand some of the very intricate, very interesting concepts that are there in our own Jyotish Shastra, Indian astronomy. A lot more can be done if more data is available. Right? Much of this was done in the last few months by just myself with no support. So a lot more can be done if in a larger project. You might have noticed that till now I did not use the terms AI or machine learning because there was no need for it. Right? Because you need not blindly apply it to everything. Perhaps if we apply that as well, more can be done. Now, is this research? Is this science? I leave that to Bangalore Science Forum to answer that. Thank you very much.
So, 1 minute. So, thank you, sir, for giving your wonderful talk on this data science. And it is very useful and benefited to our audience and the students and faculty members. On behalf of Bangalore Science Forum and on behalf of the college and management, I extend my sincere thanks to sir for your wonderful talk on this Bangalore Science Forum. I think the number is 2934, is it? 35th, okay. Thank you, sir, for coming and giving this wonderful talk. Now the session is open for question. So you can ask few questions about the topic. Yes.
Yes, you can. Thank you. Yeah.
So I had a couple of questions, but I think I'll ask one or two.
Sure.
First question I had was, so we observed in most of these calculations, like for example the yoga calculations and all, they looked at the longitude of the moon and the sun. So I was curious, why do they give so much of significance to the moon and the sun? Can't we calculate yogas, for example, like the sun and Mercury, looking at their angles?
You can. That's an interesting observation. My feeling would be, see, the inner planets, Mercury and Venus, are always close to the sun. For example, Mercury can never be more than 28 degrees away from the sun, and Venus can never be more than 48 degrees away from the sun. So they won't move so much. It's not so interesting. Right? So the three of them move like a block together, right? Because those two are the inner planets. Whereas the moon and the sun are the most interesting ones. The others are too slow. So, for example, the Saturn remains in the same place for years together.
Yeah, you don't get much interest in it.
Yeah, maybe that's why. But one can consider and see what happens if you apply the same idea to other planets. Yes.
And the other thing was, you mentioned towards the end that if we had more data of like original real people, we can do something interesting. I just got an idea that even with the data that we already have of, like, for example, Bollywood celebrities, we can maybe use that data to check if, for example, these astrological predictions are accurate. So we have data of real people who we know have become celebrities, and we have the data which, according to astrology, claims that this is the configuration required for someone to become a celebrity. We can use the data science to check whether the predictions are accurate.
So the largest data set I was able to find is about 27,000 people. And in that, about 16,000 people are born exactly at midnight, which means the time of birth was not known, and it was by default, it was 12 midnight. So we don't have the data. Even for celebrities, we don't have the data. Because a lot of these methods depend on the time of the birth, on the ascendant. So simply knowing the date of birth is not good enough. Because I already have all the data for every day. Right? So just the date is not good enough.
Okay, thank you.
Yeah, thank you. Yeah. Any other? Yeah.
Since we have this nanotechnology and also something called neotic science.
Sorry, what science?
Neotic science.
Okay.
I don't know, they call it a branch of physics. Why do you take only the planets into consideration? So when everything around us seem to affect us.
Okay. What else? You mean like asteroids and so on?
No, only planets are considered here, right?
Right.
So in cosmology, so when we have so many things, and so how do only planets, the astro bodies affect?
I think that's very interesting. I think people have gone beyond the solar system. This can be dismissed as wild conjectures. But if you just look at the way we have named the different stars, right? Why is Moola called Moola? So if you study that, one possibility is it's the direction of the center of the Milky Way galaxy. It's the source, it's the origin. That needs to be confirmed. So now we are going well beyond the solar system. Right? So all of the, for example, Ardra is the name given to Betelgeuse. Betelgeuse is nearing supernova. It might have already happened. We are yet to see it. So it's one of those huge stars which is yellowish, and you can't measure its mass, temperature, all of that exactly, because it's in a huge dynamic state of flux. And in Ardra, the real meaning means it is wet and swollen. That's the meaning of Ardra. Why was it named Ardra? How did they know that? So these are all mysteries, right? They've all been named appropriately, but we don't know how. So especially Mula, there are all kinds of superstitions about Mula Nakshatra, someone born in that nakshatra and all of that. But it happens to be the exact direction of the center of what is believed to be the center of the Milky Way galaxy, our own galaxy, well beyond the solar system. So those might have also been considered, we don't know. But in terms of what changes in our lifetimes, it is not much, right? So once you go beyond the solar system, things remain fixed. That gives us this fixed coordinate system rather than any changes happening in shorter periods of time. Yes. Yeah. Okay, thank you very much.